Okay. So I'm going to talk about tan theta. And remember, as a function, so f of theta equals tan theta. Remember that tan theta is, another way of thinking about it is just sine over cosine. So what I'm actually going to do here is build a table based on an input. I'm going to look at both the sine and the cosine value. I'm actually going to write it in the other order just because this way it's the same order as it is in the unit circle, right? This is my x value in the unit circle. This is my y value in the unit circle. So if I start with 0, and then we'll just build up pi 6, pi fourths, pi thirds, pi halves, 2 pi thirds, 3 pi fourths, and 5 pi sixths. Okay. So let's see, cosine 0. This is starting off here. And by the way, you should pause and try to build this yourself based on memory as a test of your unit circle knowledge. Okay, so if you've unpaused, here I am. This is the cosine, the x value is 1, sine 0 is 0, pi 6. Yep. So cosine of pi 6 is the square root of 3 over 2. Sine of pi 6 is 1/2. Pi fourths is root 2 over 2. Also the same here. Pi thirds is switched from pi 6, square root of 3 over 2. Pi halves is switched for x and y, 0, 1. Then 2 pi thirds gives me -1/2, square root of 3 over 2. And then 3 pi fourths is negative root 2 over 2. And this is root 2 over 2. And then 5 pi 6 is negative root 3 over 2 and 1/2. Okay, so tan is the ratio of sine to cosine in that order. So tan 0 is 0. This is 1/2 divided by the square root of 3 over 2. Well, that's going to be 1/2 times 2 over the square root of 3. So that's 1 over the square root of 3. Square root of 2 over 2 divided by square root of 2 over 2, 1. 1/2, sorry, no, see, be careful here. Square root of 3 over 2 divided by 1/2 equals the square root of 3. 1 divided by 0. Ooh, what is that? It's one of those situations that we cannot do. We cannot ask what something divided by 0 is. All right, square root of 3 over 2 divided by -1/2. That's negative square root of 3. This is -1, and this is 1/2 divided by negative root 3 over 2. That's -1 over the square root of 3. I'm going to put decimal approximations here, 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 and here. 1 divided by the square root of 3. 0.577, which means that this is negative 0.577. Square root of 3. 1.732. Negative 1.732. Okay. So tan as a function can be thought of as just the combination of sine and cosine, putting them together through division. And of course, that has implications for the domain, because anytime that the denominator is 0, we're going to have a problem. So we're going to have a bunch of spots repeatedly where we get these undefined values. And what ends up happening is we end up with a graph that has an infinite number of vertical asymptotes. And if you don't remember what a vertical asymptote is, I wish I had some good asymptote jokes. Basically, it's a line that is happening because of a hole here, an input problem, right? We cannot input pi halves. And so what turns out, and you'll do this if you go into calculus, as you look at what happens as we get closer and closer to pi halves, this value blows up because as you get closer and closer to pi halves, when you're talking about cosine, that number gets smaller and smaller, closer and closer to zero. When you divide by things that are closer and closer to zero, it ends up magnifying the numerator a lot. So like, divide something by 0.1, divide something by 0.01, divide something by 0.001 and see what happens. Whatever, take the number 5 and divide it by those things and see what happens. As you get closer and closer to zero, that explodes into a bigger and bigger number, which is why this is going off to infinity. And then we start on the other side back at negative and we come back up and we're over here. So that's the tangent graph. We can do the same thing for secant, cosecant, cotangent. I feel like we do more of that in chapter 8. So don't get too hung up on all of the extra details now. We'll dig more into that when we get in there. But just the concept of functionality, taking it, extending it from sine and cosine into tangent. That's what I wanted to show you here.